Hello everyone, my name is V. Pawansar Srinivas. I am from CSITP section. My roll number is C7. My topic is about high power and high order random variable RAM fiber lasers. High order random RAM fiber lasers are investigated for generating high power wavelength tunable light sources. By cascading random RAM lasing and adjusting pump laser wavelength continuously, wavelength tuning from 1 to 1.9 micromillimeters is reported. For power scaling, a high power Vib doped fiber laser at 1064 nanometer with improved temporal stability is developed as the pump's code. The ninth order scaled random RAM fiber laser with a spectral purity of 86.6% is achieved at 1806 nanometer. Up to 101 volts in band power is obtained with an optical efficiency of 38.4% from the 1064 nanometer and 27.2% from the 1915 nanometer. The results prove that scaled random RAM fiber laser is a versatile technology to generate high power fiber lasers at wavelength outside the rare earth emission bands. Recently, random RAM fiber lasers RRFLS have drawn expensive attention to their simply cavity-less configuration, high efficiency, and wave agility. As a result, they find diverse applications in the scientific research, optical communication, and industrial communication. Since the first demonstration of RRFL in such much efforts are put on the performance improvement. For the power scaling, the output power of the RRFL increased from the 100 of milliwatts to 100 of watts and even to kilowatts with a master oscillator power application MOPA configuration. For optical efficiency, RRFLS demonstrated pump to stroke a wave configuration up to 89. For the polarization characteristic, linear polarization output due to the polarization dependent. Raman gain was reported with RRFL. As mentioned above, lots of effort were paid on the power scale of RRFL at 1080 nanometer up to kilowatt near narrow line width random fiber laser was reported with a MOPA configuration. At 1178 nanometer, 100 watt linear polarized random RAM laser was achieved with an half of open RRFL cavity. At 1230 nanometer, 91 watt high order random RAM raising in a polarizing maintaining fiber with 77% efficiency and narrow bandwidth was reported. However, for RRFLS with more than 10 of the watts power, the wavelength range was limited within 1 to 1.2 micrometer, which is still within the emission spectrum of widely doped fiber. Power scaling of the high order RRFL at a wavelength from 1.2 to 1.9 micrometer will truly demonstrate the wavelength versatility as compared with the rare earth doped fiber lasers. In this paper, our recent works on ultra-wide wavelength tuning of RRFL is reviewed briefly at first. Cascaded random RAM raising the tuning of the pump laser wavelength are coordinated in an open RRFL to realize a continuous wavelength tuning from 1 to 1.9 micrometer. After that, power scaling of the high order RRFLS is investigated. This is the diagram of the schematic diagram of the half open RLF in the low power wavelength tuning experiment. Tunable pump laser. It consists of a container, CMS, IOS, coupler, and a temperature up to 66 Kelvin, and conditioner, LED, and CMS. Then it is connected to half open RLFLS. This is Raman fiber and IOS and WAF. Continuous wave tuning output spectrum plotted for every 20 nanometer from 1 to 1.9 micrometer. The wavelength of the normalized spectra. It is consisting of 1000 to 1900 and normalized spectra of 0 to 1. The wavelength is noted in nanometer and normalized spectra is noted in AU. The experimental steps included two functionally different parts as shown figure 1. A tunable YB-doped fiber laser is used as a pump laser and half-open RRFL. The pump laser has a standard MOPA configuration using all PM active and passive fibers with a core diameter MFT of 10 micrometer and numerical aperture of 0.075. As the graph included, the wavelength of the output power is greater at red spot and normal at blue spot, and the pump power and output power has constant. YDF pump laser is normalized by increasing the cavity length of the seed oscillator. The pump laser power is increased to 250 watt and the laser setup is modified to withstanding the power. With a 240 meter long RFL, high spectra purity 86.6% laser at the 9th RAN stroke of the 1806 nanometer is achieved with an in-band power of 101 watt, which is corresponding to an optical efficiency of 38.4% from the 1064 nanometer and 27.2% from the 1915 nanometer. To the best of our knowledge, both the tunable range and the power at the 1806 nanometer are new record for the random Raman fiber laser. They are pumped by the laser diodes which have nominal 4.8 decibel per meter and absorption at 1976 nanometer in the gain fiber. The tunable seed laser has a ring cavity geometry and tunable bandpass filter TBDF based on the thin filling cavity is used to select the operating laser wavelength, which is tunable from 1000 to 1099 nanometer with a tuning resolution of 0.02 nanometer and a bandwidth of 1 nanometer at 3 decibel. The 1020-1080 nanometer wavelength range, the whole pump laser system is all fibered and polarized and maintained. The output power and optical efficiency for the different Raman Stokes light with respect to the pump power are summarized in figure 8 and figure B. Clearly, threshold behavior is observed in the power and efficiency of the curved different Raman orders. Above the threshold, the first order Raman laser starts into the grow and pump laser dissipates until almost all the pump lasers is converted to Raman lasers. Then the second order Raman laser repeats the same process and soon on from the higher order Raman lasers, the higher order Raman lasers are generated successively. The maximum output power for each order increases with the order number. Because high order Raman lasers is generated at a high pump lasers. The highest output power of the power at 1676 nanometer and 1806 nanometer are 6.9, 69.9 and 101 watt respectively. In summary, the wavelength versatile and power scaling of the high-order RRFL are demonstrated by continuously tuning the pump laser wavelength and increasing the pump power. RRFL tunable from 1 to 1.9 micrometer is achieved, pumped by a temporary stable 0.64 nanometer laser up to 9 powder castable Raman random fiber laser at 1806 nanometer is investigated. The highest output power received reaches over 66.9 and 101 watt at 1676 and 1806 nanometer, corresponding to an optical efficiency of 42.4 and 38.4 percentage from the 1064 nanometer pump laser, respectively, to the best of our knowledge. Both the wavelength tuning range and the power at 1676 and 1806 nanometer are the new record for the random DAM fiber laser. The RRFL output is limited by the available pump power. To obtain high power output, pump laser with a high power should be developed. It will increase the Ramans again to decrease the length of the Raman fiber and overall loss. Future work will be contracted a further power scaling of the RRFLs and explore the application of such ultra broadband tunable random for fiber lasers. Thanks for giving this wonderful opportunity for me.